everyone, how are you? Welcome to this yet another session on your very own channel, BYJU'S 9th and 10th. Today it's time to have a one-shot revision and a mind map session, right? So today is something we need to revise because light is completed, right? It's good to revise it, and there's one more reason, a secret reason, which I don't know how many of you know this, but it's good if you revise it because you know what, next session we have a mentee session. I don't want you to just बेइज्जती मत करवाना, right? So that's why. So hey everyone, let me know if I'm clearly audible and visible because I can see the chat is frozen. If people are not there, or are you there? Because yeah, that's heads up, thumbs up, whatever you want to say, just do it. Perfect. Nice. Hello. Hey. All right. So, this revision is important because one thing, you have a mentee session with biology. So, be prepared. At least you'll come prepared. And we also have this as a mind map, right? So, because it's a big chapter, I have already told you, this light chapter is kind of big, kind of confusing for a lot of students. So, that's why let's revise it completely. First time, let's have a look at this as a chapter, whatever we have learned. Okay, so that's why, है ना? Mentees today only, next 6 p.m. So that's why we have a hard limit of 45 minutes because I want to give you 15 minutes break also in between. All right, so that's why. So हाँ आज mentee भी हो रहा है ना? आपका दिली इच्छा पूरा होगा. You'll get mentee also today. Yes, in the next session. But before that, let's revise everything. Let's make this mind map very quickly. We won't spend time because whole chapter is completed. We have done everything, I would say, in very much detail. Good enough, na? Very good. Okay, nice. So till now, if you have any problem in any concept, I would say go ahead and after this session, after the mentee, you can watch that particular session. But today, let's revise everything in one go, right? The complete light in this one shot. All right? Fine. Good. So, Acha, just one question before I start, revising this particular chapter to everyone. How many of you now think, because in the starting also I have asked this question to you, and a lot of you said light is a big chapter, it's a difficult chapter. At least now that we have completed all the concept sessions, how many of you think that, it's okay Disha, how many of you think that now this chapter feels easy to you, right? Hey Anshita, I'm good. Thank you for asking. Hey, yes, I can see guys, I can see all your names, all your comments, and yes, welcome. So, it's damn easy, huh? Disha, you are a senior. Yeah. Right, so Ganga, you say, Mukesh, you have problem, Magnification, ASH, you, Manoj, nice. So now you feel confident enough at least in this, huh? Hey, Gigi, I think, right? Or Suresh. Nice, it's easy when concepts are clear. That's true. So you can rephrase my question. Are concepts clear now? अब तो ठीक है ना? Concepts तो अब clear होंगे, right? हाँ, solve more numericals. A very valid point. Yes. All right. So, are you ready to revise the light chapter as a whole? Come on. Let's do it. Let's do it very quickly. Nice, Disha. All right, ready? Shall we move ahead? Come on. Light is difficult. It's not, don't worry. All the previous sessions, just have a look. Everything is done very nicely, है ना? Questions, we will practice. Today only we will practice, okay? All right, chalo. And just before I forget, this particular thing, we already have done one session yesterday, but I still hope people who do not know about this, you can use this code and you will get the 3-pack session for free, all right? And if you are facing problem, by the way, if you are facing problem, let me tell you, the moment you apply this code, it becomes free, and then you have to put your address, name, number details, and then you just go inside. It tells you that you are subscribed, right? That you have subscribed. Kal ka surprise Disha yahi tha. So this was a 399, but if you use this one code, it becomes free, है ना? No, it's a blood test. All right, it's okay. So that's why inside that, once you have subscribed, then it gives you where to go, how to attend those sessions, how to book slots, you know? So all, and which slots you can book. So all these things come naturally. So first thing is you can go ahead, apply the code, and without paying you can subscribe to it. Okay? All right. It's not working because yesterday I saw all your comments. After that I tried it myself. It was working for me. So people for whom it is not working, know that shop.byju's wala link. It is there in the description. The first link, it is there in the description, right? And I think it is pinned also in this chat. So you go ahead and try it. It will work. It will work definitely. All right, fine. Chalo. And you know what you will get inside, no? You get all the 2-tier advantage, guidance, live interactive classes, after class assignments. Because all these things I'm mentioning because they are something we are not able to concentrate a lot on YouTube. And that is why this is something you can go ahead and try. Okay? Chalo, let's move forward. Come on. Let's start with light. Let there be light, right? This is our chapter. This is how we started the concepts, right? So, no, guys, it's okay. I'm fine. It was just a blood test in the morning. Yes. Chalo, light. So, in light, majorly there are two segments, right? Reflection and refraction. In reflection, we have a whole world, and refraction, we have a complete world, right? So, let's start with one of the world. The one of the world is reflection. All right, fine. Okay, chalo, very quickly. Now, you have revised all these things, you have learned all these things. That's why I want responses, I want interactions, I want support from your side, by the way. Yes, I accept, Raghavan. It's a lengthy chapter. That's true. But there are a lot of interconnections, which I have told you how you can interconnect. Na? So that's why. Come on. Reflection of light. In very simple manner, we know what is reflection of light, right? We know it is the bouncing back of light into the same medium after striking the surface, right? We know that, correct? So, there are two laws of reflection. You know that, no? There are two laws. First one is easier to remember at least. Angle of incidence equals angle of reflection, correct? Second one is angle of, no, not angle of, incident ray, reflected ray and normal. They all lie in the same plane, and I have explained this very, very clearly. What do we mean by saying in the same plane, right? So, fine, this is our two laws of reflection. Easy, fine. So, this is first one, angle of incidence equals angle of reflection. Second, incident ray, reflected ray and normal lie in the same plane. Two very simple and very easy laws, right? In same plane. Very good, Prasanna. Yes, nice, Aarti. Right? All right, okay. So, reflection is fine, okay. All right. Now, in reflection, we started with the simplest of mirrors. It was the plane mirror, right? So, in plane mirrors, whenever I say plane mirror, I want you to just open the doors of plane mirrors in your brain. Plane mirror ke baare mein what do I know? So I'm also telling you, that tomorrow when you have a look at this mind map, how to revise this. Plane mirror ke baare mein, whenever you look, plane mirror, sir, I know properties like object height equals image height, object distance equals image distance, right? Virtual image, correct? So all these things I want you to revise the moment you see plane mirror. Fine. So let's see. Plane mirror. You know what happens in plane mirror? Image properties are same size as object. It's a virtual image, correct? And it is erect and laterally inverted, correct? Hey Saksham, I'm also good. Thank you. All right. So regarding plane mirrors, I should be able to remember all these things. It's a virtual image because it is inside the mirror. I cannot touch it. Okay. It is erect also because if I'm standing straight, image is also standing straight. Okay. Next, how far am I from the mirror? Same distance as image inside the mirror. Okay, my height equals image height. So all these things should come naturally like this whenever we think of plane mirror. Okay, fine. Yes, good. So plane mirror done. Now in our sessions we also said mirrors may there is one more category, right? It's not natural that every time a mirror will be plane. It could be curved. Now curving ke there are two ways. There are two ways of curving. One is curving outwards, one is curving inwards. Curving outwards वाला क्या होता है? Convex or concave? Incident, Manas, I would say incident angle. Angle of incidence equals to reflected angle. Incident ray equal to reflected ray. It's not actually. Curved outward is convex. Yes, correct, Raj. Very good. ASH, nice. So curving outwards is convex, curving inwards is concave, and we have remembered this, no? Curving inwards, acha, it's a cave, so concave. It's a vex, it's bulging, it's a vex, it's convex. Bas, itna, ठीक है? Alright, chalo. So in reflection we have spherical mirrors. Acha, why do we call them spherical mirrors? Can someone just give me a small line about that? Why do we call these as spherical mirrors? Nice, correct, Manasvi. Right? Because they can be assumed to be part of a sphere. Correct, Tavish? Yes, ball-like mirror. Raj, correct. You can say ball-like shape is spherical. So, we call them spherical because we can assume that there was a sphere. I cut that sphere and I get two types of mirrors. So that's why. Because they were a part of a sphere. I won't say they are. You can assume they were a part of a sphere from which they have been cut. So they are a section of a sphere. So that's why we call them spherical mirrors. Fine. Okay? Alright, nice. Because I won't say they are in circle. Circle mein to plane mirror bhi ho sakta hai. It could be a circular plane mirror also. That's why. Alright? Okay? So, spherical mirrors mein. Now, it depends, and you told me by the way. So whichever side I polish, whichever side you polish, does the polished side becomes reflective or the opposite side becomes reflective? I have dealt this in the session, by the way. Yes, Suresh, it can be, yes. If you place it below principal axis, it will become erect, correct? At least in the case of concave mirror. Opposite side. So, Raj, if you polish on this side, if you polish this side, it becomes reflective, right? If you polish this side, this side becomes reflective, correct? So opposite side becomes reflective. This is important because I'm telling you, polished side, you can, and you have asked this to me before also, sir, why not polished side? Why it's not possible that polished side becomes reflective? It is, but if you look at your mirror, if you somehow in your life you might have seen a broken mirror, no? You might see it's black from the back side. Why? Because there is polishing, but to support that polishing, they give another layer of support, right? That is the support to this polish, so that this polish should not go away like this. It's a very thin polish, no? It needs protection. So to cover that polish, you cover it with another supporting material, and that's why this side becomes reflective, है ना? Yeah, in olden days, we used to call polishing from mercury. Alright, cool. Chalo, theek hai. So silver coated inwards is a convex mirror. Silver coated outwards is a concave mirror. Okay. So I have made this point again. It's clear na. So don't be confused. Sir, polish wali side reflective क्यों नहीं हो सकती? हो सकती है. हमको उसको support देना पड़ता है. We have to support that polished side. That's why opposite side becomes reflective. Okay. Fine. Nice. चलो. It's a sphere. अच्छा, sphere के अंदर there is some radius. Right? There is some center also. So that is the center of sphere. And the distance from the center to the sphere surface is the radius. This though we all know, correct? Right? So, what we can say? In mirror terminology, this is very important, and I'll just do it like this because you all know this. Hai na? Just keep listening, and in your mind just keep repeating and answering in the chat also. Hai na? Principal axis. Nice. Principal axis is the line joining center of curvature and the center of the mirror. Pole. Pole kahan pe hota hai? Pole is the center of the mirror. This is the pole, right? For example, this becomes pole, the middle point, right? So center of curvature to pole, this is the line joining, we call it the principal axis, right? You can extend it beyond also. Now P is the pole, C is the center of curvature, and R is the radius of curvature. Fine, this is something which is easy. It is the imaginary line crazy, correct. Nice, very good, very good. Nice, you guys are smart. So in spherical mirrors, concave mirrors are called as converging mirrors because when a parallel ray of light falls on those mirrors, it reflects back and converges at a point. That point is what we call as focus. And you know what? It is the definition of focus also. So tomorrow if someone asks you to define focus, we say it is that point, right? Focus, it becomes that point where the parallel lines, right? The parallel rays which are parallel to, I would say the light rays parallel to principal axis fall on the mirror and they either meet or appear to meet after reflection. That is the point we call as the focus for a spherical mirror. Okay? Hey Yash. Mirror formula, it's coming, Yash, by the way. And don't worry, light chapter ka na, there is a whole playlist on the channel right now. And we have all the sessions we have done till now. So whenever you have any doubt, just refer to those videos. Don't worry, hai na? Nice. Yes, I'll come to that. Don't worry. We are midway, है ना? अभी हम जा रहे हैं उस पे. So ठीक है. F is the focus. For convex mirrors, we have focus to the right. Now, this is important. This is important that whenever you listen about concave mirror, ठीक है, it is reflecting inwards. It has a real focus because actual में in reality light rays meet after reflection, but in convex what happens? In convex it's a virtual focus. Why? Because light rays actual में तो they don't meet, but if you trace them on the other side, they appear to be coming from the focus, है ना? Right? Jayesh, I'll do it, don't worry. So this whole session, no, it will be given to you as a PDF in the Telegram group. Don't worry about formulas, है ना? Don't worry about currently making the diagrams because you know all these things, है ना? Don't worry, ठीक है? Yes. So important thing is it's a virtual focus in terms of the convex mirror. It is to the right. In concave, it is to the left. Okay, fine, है ना? Yes, I think one day I gave you this, but in Akash BYJU'S channel you will get it, है ना? Don't worry. Yes, PC equals 2 into PF. What is PC? PC is radius of curvature. PF is focal length. So focal length is half of radius of curvature, or you can say radius of curvature is twice of focal length. This is an important thing, है ना? Nice, good, okay, बहुत बढ़िया. So with this we have said laws of reflection in spherical mirrors, they hold true. Now this is one trick question which can come to you in any exam. Are laws of reflection valid for spherical mirrors? Are laws of reflection valid for rough mirrors or rough surfaces? Wherever there is reflection, laws of reflection will be valid. Just forget about if it's rough, if it's plain, if it's curved, doesn't matter. If there is reflection, it means laws of reflection are being followed. Maybe, है ना? अरे depressed क्यों भाई? Anshita, hold on. Why are you depressed? Yes, it is valid, no? So it is valid for all the surfaces, right? So for curved also, same thing. Angle of incidence equals angle of reflection. Incident ray, reflected ray and normal lie in the same plane. Okay, fine, alright. और depressed नहीं होना किसी को भी. चलो, next. Spherical mirrors are fine. Then we have image formation. Because if it's a mirror, there will be an image, right? So let's see what kinds of image, right? Now this is where this becomes a little tricky because a lot of cases comes. Again, I have told you, we have done. Acha, theek hai. So I'm taking this one question from Manasvi because this is a kind of question which some of you might also have. So let's say there is one rough surface like this, right? And it's a reflective surface also. One, the parallel rays come, right? When the parallel rays come and fall on this, they might seem to be going in different directions, right? You might think this is going like this, you might think this is going like this, you might think this is going like this, and this is going like this. It feels like the reflection is not, it's how are the laws of reflection being followed? But you know what? At each incident point, if we look, then if you draw the normal, the blue one is the normal. If you draw the normal, you will get to understand, oh, at every point, actual में angle of incidence is equal to angle of reflection. So it's okay, right? So that's why I took this question because this question, some of you might also have this doubt. You know what? That's why it's okay. ठीक है? All right. I hope the doubt is clear. Fine. ठीक है. So in wherever reflection happens, laws of reflection are there. Okay? Yes, correct. हाँ Disha, that's you can say that. You're correct. Nice. All right, बच्चों. चलो. So these are special rays. Now parallel rays after reflection go through focus. We know that. So rays going through focus after reflection become parallel. That is also something that we know. है ना? Now this is important. This is important. The rays going through center of curvature, they retrace their path. Why? This is one question to all of you because I am assuming all of you know this. Chalo, tell me. यहाँ पर why did it retrace the path? What was the reason? Right? What was the reason? Nice, study with these. 90 degrees mirror, correct Disha. Very good, Suresh. Normal. Yes, normal. Future billionaire thoughts. Heavy name. Very good. It's perpendicular. Right? So if in any circle, let's say any circle, so I'm taking a 2D version of a sphere, na? Any circle from the center, if you put a line on the surface, it is actually 90 degrees, right? It is like 90 degrees to the tangent. So that's why, है ना? It is actually 90 degrees. And what happens? What happens to a ray that falls on a mirror at 90 degrees? What happens? It goes back. Simple. It retraces the path. Retraces the path. It's a tongue twister, by the way. Right? Cool. All right. Chalo. Images formation by concave mirror. So all these cases we have already done. We have done multiple questions on them, right? We have done multiple interactive questions on them, I would say. So all these cases, and I know a lot of you are afraid of these cases, but you know what? See, we have also done tricks how to remember them. And if you practice, you would also understand there is a pattern to it. Sir, what is the pattern? वो pattern क्या है? Here is object beyond C. Here is object at center of curvature. Here is object between C and F. Here is object at F. तो यहाँ तक तो एक segment है. From here till here, this is one continuation. What are you seeing? Object is, yes, please ask the doubt. Yes, Sangram, true. It will be. At that particular point, I will be equal to R. Okay? Yes, ask the doubt. Come on. Right? Nice. So, first में object is very much beyond C. Alright. And there was one more case when the object was at infinity. That's okay. So, object is beyond C. Then it is moving towards C. Between C and F. At F. So, what is happening? Object is going closer to mirror. Image is going away from the mirror. Okay? And vice versa. Nice. Very good, Suresh. Correct. Opposite directions. Hai na? You will see object is going towards the mirror. Image is going away from mirror. You will notice one more thing. Object is going closer to mirror. Image is going away from mirror. And also it is getting bigger and bigger and bigger. Right? It is getting bigger and bigger and bigger. Small or large. It depends on the case. Yes. It depends on case. So, for example, here you have a smaller image. Here you have equal size image. Here you have a magnified image. Here you have highly magnified image. Now, this is a special case. When object is between pole and focus, you get a virtual, erect and magnified image. Okay? So, that's why this one is a special case. And this is one of the most important case, one of the most asked case. Right? So, these are the 6 cases, I would say. You are seeing 5. One case which you are not seeing is object at infinity, means rays are parallel. Magnified or highly magnified मतलब क्या होता है? So, yes, so people, what are we seeing over here? Object is this much, image is bigger than the object. But यहाँ पर क्या है? Object is this much, image is very far at infinity and it is highly magnified. So, it's a comparative term telling you, is it very, very big or very big? है ना? You say no, today I am happy, today I am very happy, today I am very, very happy. इस तरह से, ठीक है? Fine. and this is magnified. Simple. It's a virtual, erect and magnified image. So why this case becomes important? Because this is the only case in concave mirror where you are getting a virtual image, a erect image. Otherwise, if you notice, in all the cases you are getting inverted image only, है ना? You are getting real image only, है ना? So that's why these 6 cases एक तरफ, this one case एक तरफ. So if you remember it like this, life becomes easier, है ना? In case of object at infinity, infinity पे क्या होता है? Parallel rays, they come and they converge at focus. Real inverted, highly diminished, point size image, kind of a point size image, है ना? बस. All right. Fine. Nice. हाँ, degree of adjective जैसा, kind of, you can say that. Good, easy, है ना? Got the pattern. I'm saying कि इसको रटना नहीं है. Nice, yes, correct. Yes, virtual, erect, upright and diminished. Same thing. Convex mirror में you have all these special rays. Parallel one. The second one is directed towards focus. Third one is directed towards center of curvature. Fourth one is directed towards pole. So all these are also special rays. You can choose any of these rays whenever you want to draw a ray diagram. And we have done a session on ray diagram as well. How to show infinity image is real? You know, there is one way. For that, if let's say parallel rays are coming like this, no? Thoda sa teda. So what happens? They come and they meet at this point. This is your focus and this is your image. Chota sa image. So that's why. कॉनकेव में F क्या होता है? कॉनकेव में F फोकस होता है ना? कॉनकेव, in concave mirror what is F? All the parallel rays, they fall on the mirror and they converge at a point which we call as focus. And in one session I have also told you difference between focus and principal focus. ये remember है ना? You know that, right? Principal focus तो ये है. Focus could be any point in this plane. है ना? You remember that, no? Correct. So in this case also, they were converging here, and this was the image, chota sa image, right? And this point was F. Easy. Lens maker पे तो आएंगे. We'll come to lens maker. When the object is at focus, image will be at infinity. It's inverse. When object was at infinity, image was at focus. When the object is at focus, image will be at infinity. ठीक है? Easy. चलो आगे. Now image formation by convex mirror. This is very, very easy, I would say, because whatever happens, you always get a virtual, erect and diminished image, right? That's true. So these are all parallel rays. They, after reflection, they seem to be coming from this F, right? Agar ye rays, if you turn them, right? If you make them like this, let's say, if you make them like this, then also they will converge, but somewhere around like this. ठीक है? Virtual image, always diminished. Principal axis and principal focus. Dost, this line is the principal axis, right? P axis, and this F, that point on the principal axis where the light rays either converge or either meet after reflection or appear to meet after reflection, that point को हम बोलते हैं principal focus. बस ये difference है, right? Focal length क्या है? Pole से focus तक का distance, that is focal length. Simple, right? So always produce virtual, erect and diminished image. Easy. No doubt about this, right? Chalo, next. This is image formation. Acha, applications. Now this is one more place where we have a lot of questions, right? We have a lot of questions from here. So very quickly, dentist mirror में क्या होता है? Concave mirror. Why? Because in dentist mirror you want to see a virtual, erect and magnified image. So in applications, I have told you one easy way of remembering. Whatever application is that, just think of what is your requirement. By dentist को क्या चाहिए? What a dentist want? A dentist wants to see an image which is bigger, which is virtual, है ना? So it becomes easy for him to do all the small, what do I say, RCT or any filling or anything. So that's why. Requirement पता चल गई. कौन सा mirror देगा? Which mirror can give you erect image, magnified image, concave mirror? In which case between pole and focus? You got the answer. Solar furnace. Requirement क्या है? What is my requirement? Sun is at infinity. Okay. Means rays are parallel. Solar furnace, I want to converge them at a point so that I can heat that thing. Oh, I will use a concave mirror again. है ना? So this is how you rewire your brain to think of the correct answer. ठीक है? So that's how solar furnace comes into picture. ठीक है? Because you are using a kind of a case of that concave mirror, right? Converging mirror. That's why. Torches में what do we have? What is the use of torch? Sir, torch में I want the light of torch to go as far as possible, right? Okay, then what should I do? If I keep the object or the bulb at focus, what will happen? The light will fall and it will go straight. Now it's a good torch. Bas. Jayesh, numerical we are doing in the next session, and that's why we are revising all these things. Application of solar furnace. Solar furnace, dost, we use it as a solar cooker also. Solar furnace. So you can see this is a vessel kept. So what are we doing? You can actually make food in this. You can boil potatoes or whatever you want to do. Hai na? Yes. So correct. So yes, automobile के साथ भी this similar kind of thing. In automobile also you want the same thing, that the light from that car should go as far as possible, right? So that's why what you do is you put the bulb at focus and the light becomes parallel and goes far. एकदम सीधा. ठीक है? So automobile में we say concave mirror, है ना? गलत बात. ASTK gamers. Yes, headlight. Correct. How are images in concave mirrors? ASH, in concave mirrors, so we have done this, no? If you have any doubt, go ahead and just watch the last session on the mirrors, you will get this, okay? Fine? Nice. Chalo, let's see. Application of convex mirrors are surveillance and safety mirrors, right? It is rear view mirror, right? It is wide view mirror, alright? So wherever you want to see more area, you want to see greater area, right? Future billionaire, we are doing a session on that, right? Okay. Yes. So that's why convex may there are two advantages. It can cover more area, right? And it can give wider field of view. It will give you always virtual, erect and diminished image, correct? है ना? Magnification पे yes, I am coming to it. Don't worry. It used to, in vehicles, bulbs used to be there, अब तो LEDs आ गए हैं हर जगह, right? Alright, चलो. So this is how the applications of mirrors. Now the last thing about reflection and all the mirrors is magnification, right? So let's see about magnification. Before going to that, we should be very clear with mirror formula and magnification, right? Mirror formula तो आना ही चाहिए. अच्छा, headlight reflect. See, torch and headlight. In both, what do you want? अच्छा, I'll explain you here only. What do you want? You want that light should go as far as possible. Now, that's why you can see as far as possible. So you keep the bulb at focus. From the bulb, rays will fall on the mirror and they will become parallel. And that is how your requirement is being fulfilled. Okay? Right? Wide view mirror, dost, it is being used at surveillance, parking lots, right? There you will see wide view mirrors. Chalo. So direction of incident light. If this is the direction of incident light, and this I have explained in very detail. कि plus क्यों होगा minus क्यों होगा. तो अगर light ऐसे है, if direction of incident light is like this, it becomes left is negative, right is positive, up is positive, and down is negative. Nice. This is the mirror formula. Yeah, Jesh, camera में it's a little complicated. I won't go into that right now. But अभी के लिए तो इतना, this is good enough. And someday we'll talk about. Nice, very good, future billionaire. So This becomes the mirror formula, and yes, I have promised you that I'll share you the derivation of this also, and don't worry, I'll do it. I have that in mind. I'll just give you a small recorded thing, because in the live I don't want to waste everyone's time. People who want to watch, they can watch it afterwards, right? Okay. So I'll give you this mirror formula, and magnification is hi upon h naught. अच्छा ठीक है, न्यूमेरिकल होगा दोस्त. पहले we have to cover everything, right? Concepts clear होंगे, then you can move to numericals. What is the point if I tell you numerical first and tell you concept पढ़ के आ जाना? अच्छा लगेगा आपको ऐसे, है ना? क्या सुष्मिता? अगर मैं न्यूमेरिकल कर रहा हूँ और आपको बोलूँ पढ़ के आ जाना, न्यूमेरिकल करेंगे यहाँ पे. What do you think? Will it suffice for you? I don't think, right? So mirror formula में it is 1 upon v plus 1 upon u is equal to 1 upon f. What is v? V is the distance of image from the pole. U is the distance of object from the pole, है ना? Right? So f is the focal length, right? It is the focal length, correct? है ना? So this is the mirror formula, and whenever you keep v, u and f, it becomes important you keep them with proper sign convention. ठीक है ना? So magnification में क्या होता है? Definition is it's a ratio, correct? As Anshita is saying, height of image upon height of object. That is, it's a ratio. है ना? Magnification मतलब क्या होता है? कितना बड़ा हो गया. So height of image upon height of object. Now it is height upon height means it's a ratio. Magnification का unit होगा? नहीं होगा, right? Hey Parvati. So magnification will have no unit. Why? It's a ratio of length upon length. That's why. So, and it is minus v upon u. This is again, it came from derivation only, and it's an easy derivation. Don't worry, but I'll share it with you in a video. Minus v upon u is the magnification. Now remember, yes, cases in mirrors I have taught, and if you have missed it, don't worry. Hey Gracie, yeah, on harder numericals we'll do it. We have the challenge yourself sessions also. We'll do that, but before that, concept should be clear, no, to everyone. That's why, है ना, Gracie? So, ठीक है, minus v upon u is the magnification. All right, fine, बढ़िया, चलो. So with this reflection part is done. Now you know what? Refraction is like an alter ego of the refraction bit. इस दुनिया का ना एक और part है, and there is lot of relation from reflection. ठीक है? So that's why. Try to see, be attentive, and you know what? We'll finish refraction very quickly because we have questions. In next 20 minutes we have questions, and I want to give you time also to relax and take a break. Ruhani, it is almost slightly here and there होता रहता है. ठीक है, चलो, refraction क्या होता है? Bending of light होता है, सर क्या ही है इसमें? What is refraction? It is the bending of light. Simple. All right. Then when it travels from one medium to another, right? It's the bending of light. Very simple words, from one medium to another. अच्छा sir, two mediums. What is the difference between them? They are transparent. One is the similarity. Second is they have different optical density. Sir, optical density. What is optical density? It is how slow the light is becoming in that medium. And that is what we are calling as optical density. It's a rarer medium. It's a denser medium. So there are laws of refraction as well, right? Denser to rarer. And ये density वो नहीं है mass upon volume. So if I tell you in very simple words, density मतलब क्या? Optical density मतलब क्या? जिसका refractive index ज़्यादा है, वो ज़्यादा optically denser है. Whatever has higher optical density is a denser medium, right? Or it has more refractive index also. So optical density means high refractive index, kind of. ठीक है? Easy. चलो. There are laws of refraction as well. पहला law तो simple है, because this is the same thing you had in the laws of reflection also, right? Nice, correct. X2, XY gamma, right? Denser or rarer denser, same, Tavishi, correct. So first one is easy because this is same as reflection one. Second one is important. What is the second one? Can someone tell me what is the second law of refraction? Anyone? Higher and rarer, Vinod. Snell's law, correct. Nice, Manasvi. Very good, Anshita. Nice, Rohani, Tavishi, very good guys. You remember, na? Snell's law. I think it was an autocorrect, na? Elizabeth. It was Snell's law, came out to a Snell's law. But nice, I understood. Nice, Parvati, very good. So yes, second one is Snell's law. And this is very important, because a lot of refractive index questions, harder numericals, they will be using Snell's law. So that's why. It's a very simple, but still a tricky law. I'll tell you why. Sin I upon sin R equals a constant. Sir, I is where? I is this, right? This is I and this is R. So sin I upon sin R is the refractive index of medium 2, right? It is the refractive index of medium 2 with respect to medium 1. Correct, right? ठीक है? All right. चलो. So refraction of light, if it goes from rare to denser, light की speed, the speed of light slows down, it bends towards the normal, right? Ruhani, I'll talk about that, don't worry. And when it goes from denser to rarer, its speed increases, it bends away from normal. And why speed and bending is related, there is a law about that, but I won't talk about it right now because you might have seen it on the app also. There is a whole explanation about this, right? ठीक है. Rarer medium से denser में bends towards normal. Denser to rarer bends away from normal. So these are the final things. भाई यहाँ पर I is bigger than R and यहाँ पर R is bigger than I. So what is incident angle? It depends on what is the direction of light. This is something which I have told all of you. See guys, I know you are very eager about numericals, but you know what? This is one problem which we do. We don't learn everything. Right? We don't learn everything and we jump to numericals and then we demotivate ourselves. अरे यार numerical नहीं हो रहे मेरे से. आपने पढ़ाई नहीं है तो कैसे होंगे? That is one problem. No. So that's why. Notice I becomes what? This ray tells you that this is the angle of incidence because here it became I, है ना? Because this was the direction of light. Light यहाँ से आया और इस interface पे पड़ा. If light came from this direction and falls on this interface, this becomes angle of incidence. If it comes like this becomes angle of incidence. Okay? This is important, by the way, very important, because I'm telling you, questions will try to trap you in this one small thing, and you know what, ऐसा होता है. And but you know, I'm hoping you won't be trapped, and we'll do practice in the numericals. Don't worry, है ना? Okay, yes, first point is correct, Parvati. So again, if a light ray goes from water to oil, nice, correct. Oil is optically denser, yes, so that's why, correct. Yes, Apikon, please ask. Okay, so this was about refractions, alright. Now glass slab. Like we had plane mirror, similarly we have glass slab, the easiest kind of refraction. In glass slab, what happens? It's kind of easy. Air to glass, bending towards normal. Then it is from glass to air, it is bending away from normal. Now important thing is trigonometric ratios. Yes, correct. Parvati, yes, it will be bending at normal. You are talking about denser to rarer. There I'll talk about the critical angle. No, but you don't have it. Oh, you are saying this. So you are saying if I take denser and denser medium, is this a possibility that it becomes like this, huh? So see mathematically, right? Sin I upon sin R equals refractive index, right? Refractive index, let's say it is K. So you are saying R is 0, sin I upon sin 0. And sin 0 is 0 and 1 upon 0 is an indefinite value. So that's why it is practically not possible and it doesn't happen also. So this is one mathematical proof of that. Right? Anamika, for that, that 3-session thing, the 2-teacher model wala na, it will help you more. So live doubt solving wahan par ho jata hai. Okay? Good. Chalo. Emergent ray is parallel to the direction of the incident ray. We know that, no? Because E is equal to I. Mathematics proved it in the session. Hai na? Nice. Correct, future billionaire. That is one correct thing. If it falls like this, it goes without any bending. Right, okay. So Anamika, app ke upar, it's more interactive and it's more AI based. Live ke liye we have, and I have given you the code now. Just try that. It will be more helpful for you if you're looking for the live doubt solving for you, hai na? I mean, ye bhi live hai, but still you get personal doubt solving there. Okay? Yes, lateral displacement. Very good, very good. Yeah, that's correct. People who missed, this was the lateral displacement. right? Chalo. Next, we have refractive index. Sin I upon sin R. It was a constant. That constant was what? It was refractive index only. So n का एक definition होता है. How slow the light became, that is the refractive index. Speed of light in vacuum, that is C. Upon speed of light in the medium, it is V. So C upon V is the refractive index. It is also equal to sin I upon sin R. So, अच्छा ये this formula is very important, right? ठीक है. अब ये formula में I'm telling you why you will be confused sometimes. N21 equals N2 upon N1 equals V1 upon V2 equals sin I upon sin R. Alright. So इसको पता है आसान तरीके से कैसे लिखते हैं? How do you write it? I is in medium 1, R is in medium 2. So I will say sin I multiplied by refractive index of medium 1, that is N1, equals sin of R, it is in medium 2, multiplied by refractive index of medium 2. So this and this are the same thing, but iske andar you won't make a mistake. That's why. Yes. Correct. So Anamika, it is free for some duration. You can watch 3 videos, but you can practice a lot of questions. So app के अंदर ये होता है. You can't watch unlimited videos if you are not a paid user. वैसे तो YT free use करो, 15 day free है. 15 दिन में you can do whatever you want. So वर्मा साहब जल्दी होगा. I think Friday को है वो session. Yes, all right. चलो next. Spherical lenses. We had spherical mirrors. We have spherical lenses also. Achha, convex lens and concave lens. I will not spend much time on this because it's a direct correlation with concave mirrors and convex mirrors. Okay? Convex lens is very much like concave mirrors. Concave lens is very much like convex mirrors. So these are all terminologies. O is the optical center, C is the center of curvature, we call it the 2F, and F is the focus. Sabka definition same, right? Nahi, Raj, I haven't forgotten you. Image formation, come on. We have 4 minutes more, or 3 minutes more. Let's go. Special rays for a convex lens. You know these special rays, right? Parallel one, passing through focus, and this is passing through optical center. Now, important thing is, the ray which goes through optical center, it goes undeviated. Okay, right? Chalo. All these are different cases. Again, I'm telling you, till here, it's same. Real, inverted. Here it is different. Virtual, erect and magnified. Okay. This is between O and F. Right. So all these are almost similar to remember like concave mirror. In concave lens, same thing. Right. Parallel ray. The ray towards focus and this is towards optical center. Same thing. So image formation again similar to a convex mirror. Yes, Vinod, you are correct. Nice, Divyansh. So that's why case 1, this is similar to a convex mirror where you always get virtual, erect and diminished image. Okay? Focal length of a concave lens, again same thing. Light rays after refraction, they appear to meet at this point. They don't actually meet in concave lens. Similar to the convex mirror, they appear to meet. Okay? So that's what the image formation is all about. Next, lens formula and magnification. Now, again it is similar. देखो मिरर फॉर्मूला में क्या था VUF टर्मिनोलॉजी इज सेम U मतलब V मतलब F मतलब it's all same. U is object distance, V is image distance, F is the focal length, right? Nice, Raj, good. So in mirror formula it was a plus, in lens formula it is a minus. Why and how, don't worry, I'll give you derivation also. M is HI upon HO. It means the same thing, but it is V upon U. So, ठीक है, difference. In mirror formula, it was 1 upon V plus 1 upon U equals 1 upon F. And magnification was minus V upon U. Here it is V upon U and here it is 1 upon V minus 1 upon U equals 1 upon S. Easy, इतना ही difference है. So, with this, I would say, your mind map is completed. We have just a power of lens. Power of lens is easy. It's 1 upon focal length. Focal length should be in meters. बस इतना है ना? Focal length will be, अच्छा, it will be positive or negative similar to the mirrors only. Left में आएगा तो negative हो जाएगा. It will be right, it will be positive. ठीक है? Same thing. So, for example, convex lens, focal length will be positive. Why? It is to the right. A convex lens, focal length is this side. It is to the right, positive. A concave lens, it is to the left, it is negative. Easy, ठीक है? इतना ही है. Yes, P equals 1 upon F. And focal length in meters. Unit is diopters. Are all powers and lenses. Don't worry, we'll talk about this in human eye also. Right? So positive power for convex. Why? Because focal length is positive. Negative power for concave because focal length is negative. That's why. And when you have lenses in combination, you just add all of them. Right? Anamika, yes. And Anamika, you can put this comment in the videos comment section. And yeah, we'll have a look. But हाँ, app के ऊपर होता है. You can practice a lot of things. Free live के लिए try that, the 3 class pack which I've given you. And it's also free. Okay, alright. So, with this, you remember all the formulas. See, relation between R and F. This is refractive index. This is mirror formula, lens formula. And this is magnification. See, this notes book on this PDF I'll give you in the Telegram group. So that's why please make sure that you know this thing. We have got you covered. But please make sure you are a part of the Telegram group and the link is there in the description. You join that and I'll give you the notes in that Telegram channel itself, right? Manasvi, yes. Correct, Elizabeth. That's true. Now, you have this next session at 6 p.m. today. In 9 minutes, go ahead, take a break, and we'll meet again in 9 minutes. All right. So please make sure you like, share, and subscribe because that's important, and I hope you will do it. Okay. Chalo, take care, take break, and let's go ahead and solve some numericals in 9 minutes. All right. Thank you, everyone. Bye bye. See you in next 9 minutes. Chalo, bye.